Hey, what's up, Logic fans? I'm Ash. I'm the author of the text Bivalent Logic Explained. And in these opening 3 videos on section 1.1, we discuss section 1.1 of the book on propositions, validity, and soundness. So all videos 1.1a, 1.1b, and 1.1c discuss that first section of the text. All right, let's rock. Okay, so you pick up a logic book or you take a course in logic and you show up the first day and you're probably wondering, what is logic? Now, the definition of the field is controversial within the field, but for our purposes, okay, for the purposes of an introduction to logic, for the purposes of the textbook Bivalent Logic Explained, and the purposes of these videos, we're going to define logic very simply as the study of inference. So there's some fundamental questions that logic investigates. Questions like, what follows from what? Okay, what can be inferred? Okay, inference is the central, single-handed, most important concept in logic. Okay, and regardless if you're using our textbook or another textbook, your logic class is going to be very much concerned with the notion of inference. Okay, what can be inferred from what and why? Why does the proposition B follow from the proposition A? Okay, but C does not follow from that same proposition A. So let me give you an example. So when you take a course in computer science, one of the first things you do by tradition is learn how to write a hello world program, which essentially you sit down and you write a program that when executed prints the words hello world across the screen. Similarly in logic, there's like an introductory argument, okay? We're going to learn about these in a second, but we're thinking about inference. Now, all humans are mortal, and Socrates is a human, okay? Let's assume for the sake of argument that these are both true, and they certainly look to be true. The question is what can be inferred from 1 and 2, okay? So something follows from 1 and 2 taken jointly together. See if you can take a second and figure out what it is. Pause now. Okay, hopefully you've had a chance to think about it, right? But it's not too bad, and don't worry if you weren't able to get it. By the end of the course, you'll be able to solve problems like this instantly. But it follows that Socrates is mortal, okay? So the big idea here is that this proposition here, 3, Socrates is mortal, followed from 1 and 2, or could be inferred, okay, from 1 and 2, and that is the central idea of logic, okay? So are there systematic rules that we can articulate which sort of codify with mathematical precision inference when one proposition, such as this one, follows from one or more other propositions, and when a proposition does not follow from one or more other propositions? So logic is the study of inference. When can we make these inferences legitimately, and when can we not? And it turns out that there are rules we can codify with mathematical sort of precision which tell us when one proposition follows from another and when they don't, and we call these rules of inference, and we'll be getting into all of them shortly and throughout the text, okay, in these videos. Now, to begin with, okay, since it's one proposition that is inferred from one or more other propositions, okay, we have to begin with the notion of a proposition as a fundamental unit of study. So let's talk about propositions for a moment. So propositions are commonly defined as that which has truth value. This might be a little obtuse, and we're going to formally define propositions later, particularly in sections 1.7 and 1.8, but it's important to begin with the intuitive idea, that which has truth value. Let's start with this. Truth value, what I mean by that is true or false, and I will discuss that in more detail in section 1.2 on the Law of Bivalence in the next section. But it's a thing that can be true or false. Okay, so for example, the proposition that Socrates is mortal is either true or false, right? It has a truth value, and in fact, it's true. Okay, but that's the basic idea. Okay, and other terms for propositions include things like it's a hypothesis, a statement, an assertion. Sometimes people call it a sentence. That's not quite right for our purposes, but yeah, hypothesis, statement, assertion, It's the a proposition is the, let's say, the content or the semantic content of a sentence, let's say. Okay, so it's the meaning of a sentence. Okay, it's the thing that has the truth value. Okay, that's basically what it is. So take, for example, the proposition that grass is green. Okay, that has a truth value. It's an assertion of some kind. It's something that can be true or false. Okay, and that's the basic idea of what a proposition is. And as a basic idea, we sort of postulate, just for the sake of argument, that all the propositions exist. Okay, so let's just sort of lay it down heuristically that there's a proposition for everything we might want to assert. All right, and everything we might want to assert is a proposition. So let's grass is green. Gravity obeys an inverse square law. Socrates is mortal. Socrates is not mortal. These are all propositions. These are all things that can be true or false. Okay, and the point is that once you've got propositions, we can then wonder which propositions follow from or can be inferred from other propositions. Okay, and our fundamental unit of study for deciding that is known as an argument. Okay, so an argument, and you've already seen one. Okay, an argument is a set of propositions, so it's sort of like a collection. It's like a bunch of propositions together. Okay, but only one of the propositions that have been collected together is the conclusion of the argument. That would be this one in this case. That's what's being inferred from the other ones, and the things that are given in support of the conclusion are called the premises of the argument. Okay, so 1 and 2 here are the premises of this argument, and 3 is the conclusion of this argument. And notice 1 and 2 are given in support of the conclusion 3. All right, and as we noted, we can sort of infer 3 from 1 and 2, and so in some sense that's a good argument, but we're going to formally define the notion of inference momentarily. But the basic idea, okay, is that you've got this world of propositions. You've got all these propositions out there. Okay, George Washington was the first president of the United States. All right, you've got all these propositions, and the idea is you can sort of pluck these propositions at random out of the ether. For example, you could pluck this one out of the ether. For example, you could pluck this one out of the ether. For example, you could pluck this one out of the ether, and you can combine them in any way you want into any arrangement of premises and conclusions. So, for example, we could replace it this way. We could have this as an argument. Okay, we could have this one here, and we could have this one here, right? And this would be an argument, right? It's in a, pardon me. We could have arranged our randomly selected premises just this way, right? So we could have had, basically reversing this premise in the conclusion. We could have had all humans are mortal. Socrates is mortal. Therefore, Socrates is human. Okay? And this is indeed an argument. And if you put in, gravity is obeys an inverse square law in there, you could put any random arbitrary arrangement of propositions into a premise and conclusion format is going to count as an argument. Okay, and the basic question we have as logicians, as people who practice logic, okay, is given that randomly developed argument with a random set of premises and a randomly selected conclusion, can we sort of develop tools for investigating whether the conclusion of that randomly generated argument follows from or can be inferred from the premises of that randomly generated argument. So before we get into, the rules of inference and how to sort of determine with mathematical precision whether or not one proposition follows from one or more other propositions, let's work intuitively for a moment, okay? And look at an example or two. Let's try this here. So here's, not an argument, but part of an argument. It doesn't have the conclusion filled in, but it's got two premises, and there's supposed to be something that follows from the two premises. So the two premises are all whales are mammals, and the second premise is all mammals are vertebrates. Okay, now something can be inferred from these two. Pause now take a second and see if you can figure out what can be inferred from 1 and 2. Okay, hopefully you've had a second to pause and think about it, and if you're not getting it, don't worry about it. By the end of the course, you're going to be solving these things really, really quickly. But what follows from 1 and 2 is that all whales are vertebrates, okay? And that's just supposed to be, again, operating at the intuitive level because we haven't developed any formal techniques or methods for determining when a conclusion follows from premises or not. But hopefully you have the strong intuition that this is so. Let me try to develop that intuition a little bit in case you don't have it. So one way of thinking about this argument and getting yourself to sort of intuitively appreciate that 3 follows from 1 and 2 is to think about it in terms of concentric circles. So let's suppose that we've got all of our whales collected here into this blue area. Okay, so this represents all of the whales. Now, if the first premise is true, it says that all whales are mammals. So I'm going to do our mammals in orange in a second here, okay? But the basic idea is that if all whales are mammals, then in some sense, the whales are contained inside of the mammals. Now, we know independently that there are some things that are mammals that are not whales, so they're not going to be blue, okay? But we know that all whales are mammals. So, for example, you and I are mammals, but we're not whales. So we're out here, and we can sort of think about it this way, okay? So the mammals are in orange here, and all whales are mammals. So if you're blue, you're in the orange, okay? But by our second premise, all of the mammals are vertebrates. So let's go ahead and do that in, I don't know, purple, okay? So the vertebrates will be in purple, okay? And notice, again, okay, all mammals are vertebrates, so everything in orange is inside of the purple, which represents our vertebrates, right? So does it follow from this that everything that's blue is inside of the purple? And yes, it does. All the whales are vertebrates. So by thinking about it in terms of concentric circles, you can sort of say, okay, well, if all the whales are inside of the mammals, so to speak, and all the mammals are inside of the vertebrates, right? Then the whales are going to be inside of the vertebrates box also. So that's just sort of a way of intuitively motivating the idea. What I want to do now is give us our first technical definition of inference, okay? But in order to do that, we're going to spill into the next video. Okay, so on 1.1b, we will look at our first technical analysis of the notion of inference.